Wauw. Goedemorgen, Norge. Tusen tack för att vara här. Jag har tagit igår aftes på festen med kollegien på att ha denna foredrag på norsk. And that's where the expression drink like a Norwegian comes from. Second is, when I really wanted to do it in Norwegian, I talked to my legal department and they said, no. You're going to have this disclaimer in English. So you've seen it, we have had this part, thank you so much. Legal is happy. So let's go back to the fact why this speech is in English. Your ancestors, the Vikings, did not use maps. Now, that's really a sad thing, because if you imagine that when they went to Iceland, or from Iceland to Vinland, and that Vinland map was really real, this meeting would have been in Norsk. We would all be speaking Norwegian. It would not be the United States of America, but the United States of Norway. Sadly of that, they didn't make maps, and we're speaking English here, at least in this part. Now, Here Be Dragons is the title, and there's a reason. On older maps, after the Vikings, you know, the times that raping and pillaging and burning were over, and we actually started to become really civilized people and gave up all these brilliant things like making brilliant boats, and then we found oil, right? In those days, people made maps, and every time they didn't know where the heck they were or what was going to be there, when there were unexplored territories, they used to say, "Here be dragons." And this is a little bit where we are in technology today. What we're going to talk about is what is it we haven't done before? Where is the change? Where are the dragons? And should we fear them? Or as your ancestors did, should we sail the dragon? So the times are changing. Now, how are the times changing? Watch at this picture. A world championship chess 16 years ago is crying. And look at all the nerds cheering because technology wins. And yeah, that's us. And basically, what really happened wasn't so exciting. It was the basic of a GPS. I have 64 options to place a piece. Pieces have rules. I have a limited amount of motions I can do. I just need to calculate all the options, then put some game theory in it. What would Kasparov do? What will I do to confuse him? And bang, I win. It's all calculating power. Not that exciting. So how is the world really changing? Well, this is the inauguration of the previous Pope, Benedict, 2005. Watch. One person in 2005 is very modern here, using a phone to make a picture. This is 2013, Francis. How do I explain you the times are changing? Well, we are creating much more data and we don't even realize it. And you know, the point is, it's not the amount of data that we create, it's the absolute irrelevance of data that we create. I mean, the amount of tweets that goes on. John is in the meeting, John leaves the meeting, John goes to the bathroom, John leaves the bathroom. Really? But it's like Michael Jackson died. It was like 456 tweets a second. Incredible, 456 tweets a second. They were like this, oh my God, oh my God, oh my God, oh my God, Michael Jackson died, oh my God. I mean, there were a lot. Weren't that relevant at all? I mean, okay, Michael Jackson died, we know it. We didn't need exabytes of Michael Jackson tweets, but sharing is caring in the society. So let's go back to the theme. Where are the dragons? Well, let's talk about the unexplored territory of cognitive computing. So instead of we figuring out how technology works, anybody did the iOS 7 update last week? Sorry, anyone tried for 10 hours and 40 times to do the iOS 7 update last week? And then you figure out, where the heck is my calendar? And what happened to my pictures? And that kind of, that's us trying to understand technology. The point is around, in the digitization of society and a growing of data, how can we actually get technology to understand us? Learn with us, learn language like I speak now, and actually filter data without needing a database. Let's talk about this. Why did we want to play Jeopardy? Now, for those of you who don't know, Jeopardy is an American game show, 40 years been running. And in those 40 years, you get all kinds of puns and categories. So you make fun of words, you try to confuse the candidate, and the candidate gets the answer, not the question. So the answer, for instance, would be Hilde, and then the question could be, you know, and then but that's actually the answer. So what is the question? Well, the question could be, who is the best host of this meeting? Who is the presenter? Who will pay the bar bill? I mean, you need context for that. And in this thing, you get only a little context, you get the category. Well, we're going to talk about but a category is a little bit unreliable. So you get an answer, you need to get the question, you get multiple domains, science, technology, gossip, and then you get the questions in human language you need to accurately file. So we had this, can we do this? But while we're going to play this, have a look at the left, the gentleman that's going to be here. That's the fastest buzzer in the 40 years of this quiz. This guy has played 74 game shows undefeated in the tempo of questions you're going to get. And the other side, we're going to get a gentleman who has won most money in this game show. So we're not playing against somebody, we're playing against the Kasparos of this game show. We're going to take normal language and we're going to give answers. And to already give one thing away, there is no database. There is no database of question and answers. I'm going to come back on that, but can talk a lot about it. Let's give you a little bit about how cognitive technology works. Ladies and gentlemen, meet Watson.
Good morning, everybody. Thank you for being here. What do you say we play Jeopardy? Let's get right into the Jeopardy round. These categories: a man, a plane, a canal, Erie, Chicks Dig Me, children's book titles, My Michelle, MC5, and finally, vocabulary. Ken, you're in the first position. Please make a selection.
I've never said this on TV. Chicks Dig Me for 200, please, Jimmy.
Kathleen Kenyon's excavation of this city, mentioned in Joshua, showed the walls had been repaired 17 times. Watson.
What is Jericho?
Correct.
400, same category.
This mystery author and her archaeologist hubby dug in hopes of finding the lost Syrian city of Urkesh. Watson.
Who is Agatha Christie?
Correct.
Same category, 600.
At the Olduvai Gorge in 1959, she and hubby Lewis found a 1.75 million year old Australopithecus Boise-eyed skull. Watson.
Who is Mary Leakey?
You're right.
800, same category.
Harriet Boyd Hawes was the first woman to discover and excavate a Minoan settlement on this island. Watson.
What is Crete?
Yes.
Let's finish Chicks Dig Me.
If you see this for 3 days on American television, 3 days in a row, 3 rounds, gets boring, right? So what's really happening? You see this here? This is confidence. So the technology doesn't say, I know the answer. The technology say, I have multiple answers. What do I have most confidence in? This is already different than traditional business intelligence that says it's 3.5. It's not really 3.5. At the moment we run a query on data that was 6 weeks old, we came to a conclusion it was 3.5. And in the meanwhile, life has changed. So what is really happening? Watson takes the question in normal, natural language. It works offline. There's no connection to the internet. So cognitive technology means I do language parsing and I learn language inductive like a child learns that. The second is I have multiple raw documents and multiple raw structured data. So I have a copy of the Internet Movie Database. I have a copy of the National Geographic. I have a copy of the National Enquirer. I have a copy of the New York Times. I have all kinds of sources. There is no Q&A list. Because if you could directly have a Q&A list, you would do what a human being could do with a list. And you and I don't use Q&A lists in our heads. When I'm asking someone in the front row, don't worry, I'm not coming there. So when I asked someone in the front row here, I said, Queen, Bohemian Rhapsody, was it #1 hit in Norway in December 76 or January? You're not thinking, oh, I have a list here, hits, #1 hits in Norway, Queen. No, you're going to think like, who was I dating at that moment? And when I was so annoyed with my parents with Jule Afton, what did I do and what music did I listen to? And that's how you figure it out. So this technology reads 200 million book pages a second from all the sources in the format they are. It applies a hypothesis, says multiple hypotheses, and then it says I find multiple answers, multiple candidate questions, multiple sources. I have confidence in different sources, and this is the answer. Oh, and then we had to build a bionic finger to press the buzzer, which is not really what IBM's forte is, so 42 buzzers later. Let's go to the next part. What is this really, why is it so significant? IBM started as the computing tabulating company. Now why do I force it out? Because in the beginning, the systems area was all mechanical tabulation. I did census, I added things, I had cash registers, calculators. And then in the 50s, we started to learn programming. If, then, else, do this. And the essence of computer technology today is still rule-based if then else do this, if then else do that, add this, distract it. We have more languages for it, it's more sophisticated. We went from COBOL to SQL, but the essence is still, I give a set of instructions and you'll execute. Those technology is dumb. Now Watson is actually also a complete idiot, because it doesn't think like you and I do. What it does every time when it hears the question, it doesn't have a set of if then else's. It says, what sources should I do? What have I learned from last time? So it learns, it uses machine learning instead of if then else. So the good thing is with cognitive technology, you don't do programming. The bad thing is you need to come with series of cases and examples. Now, this was 2011. We expect in 2020 to have the thinking power of the human brain. We'll have the calculating power of the human brain in 2015, and for most people that is the thinking power. But 2020 we will have an average student's brain. But it still needs to learn. So let's go a little bit on the principles, right? Data changes everything. Now, 10 years ago, when I lived in London, I could find my way around by memorizing the most important routes, like taxi drivers does. 3 years ago, I drove around London with a GPS, totally relying on it, and I talked to the manager of the parking garage at Paddington Station, just near the train, and he told me that 3 times a week, people come by car on their GPS, returning their car there, make a right, and then via the escalator drive down with their car. Because the GPS said go right, and they took the stairs, instead of taking 5 meters more and take the entrance. So it's not that the data just changes. You know, if common sense was really common, half this room would be out of a job. You know that, right? So let's go. What does it change? Let's go to the principles that we're going to take. So 5 key principles. 1, can I unleash big data? 2, can I visualize it? 3, can I share it? 4, can I predict? And 5, can I add cognitive intelligence? Because a lot of people say, oh, I like that, Watson. I'll do me 2 of those. Can you put them on a truck? And I say, well, it's not that sophisticated. It's 2,800 PlayStations stacked together. It's just Linux. Few patterns for workload management, 3,000 mathematical models to understand language and work with confidence and do some machine learning. The point is, what questions would you ask to such a system? Then, and this is also for you guys, when you talk with your business partners, and they say, oh, cognitive technology, oh, using language, I want that, my precious. And then ask, like, so what are the questions you would ask it? Okay. And do we have the data actually to feed it? Can we unleash the big data? How would we visualize it? How would we share that instead of having one data scientist sitting in the ivory tower? How would we use it to predict? So let's go to these principles, okay? Michelangelo never came in a room and says, oh, I'm going to do 25 minutes of carving, then 2 minutes of chiseling, and that's what I'm going to do with this piece of marble. He looked at the piece of marble and he saw the business value of it. He came with a business question and he said, how do I set this angel free out of this piece of marble? So let's get an example. Nearby, Vestas, Denmark, Danish company, just won a phenomenal award for what they do with big data. They found out that it's a little bit like shouting competition. The one who makes the most noise isn't the most right. I know that's hard for some guys to get, but that's really true. The place with the most wind isn't the place where you will get the most energy, isn't therefore the place that you get the most value, therefore isn't the place to actually get the best environmental friendly energy. So what they do is they take 35,000 meteorological sites of data. They marry it with all kind of data outside the firewall, inside the firewall, leading up to 24 petabytes. For those bad in math, that's 70,000 hours of 70,000 years of Netflix. 70,000 years of Netflix in HD format, that's 24 petabytes. So happy viewing. And instead of doing 3 weeks for one simple question from their customers, they do it in under 15 minutes. So what they do is they take an enormous amount of big data and they merge structured and unstructured together. They do this already for around 2 years. It's not new. They combine structured tables and databases and unstructured, like sensors or even reports or comments from engineers together. So 1, is it possible? Yeah, it's already being done. 2, where do we see it? Everybody always says, oh, come with examples of big data. And then we come with the standard, you know, I listen to the customer, I listen to social media, and then I get this. It's all true. But you know what's really going to change our world? In simple things like agriculture. The problem is when you're a farmer and you really, really have consolidated land, you do not have the ability to monitor every crop anymore. So what you do is you spray around. And what you want to do is spray less and have more environmental friendly food, more better quality food, and optimize your production because it's a very narrow margin. So drones are now being set in to figure out what's happening with the crop, what's happening with the environment, what's happening with the insects, and even when you're environmental friendly and use wasps, etc., do we have enough insects covering this area? But those drones generate more data than Netflix does in 70,000 years. So, big data and precision architecture. Second part, again, how do you, so now you have a lot of data. Let me give you an example. I have 25,300 songs in my iPhone. Great, it's unleashed. Now in the old days, you did this, or you did this. And when you had a party, you wanted to make a playlist, you went to one of your shelves and say, this one, this one, this one, this one, this one, and you had a stack for the party. Great. Now you have a party and you spend 2 frickin' hours going to your playlist, to all your 25,000 songs, just to make 1 hour of music you want to hear tonight. So visualization is actually even more important because unleashing big data, really, ladies and gentlemen, there's one little caveat there with unleashing big data. You're not going to use the standard technologies that you learned in database schools. SQL and those kind of things are good to get data out of a structured database, but there's so much other data that you need to combine that platforms like NoSQL and Hadoop, etc., have become really relevant. So we're already expanding technology. Now we have to change visualization, and not just technology-wise, we need to think. So an example I'm going to give you, this is Memorial Sloan Kettering. We did this with Memorial Sloan Kettering, and Watson was the first job was going to healthcare. We used cognitive technology to work on cancer, battling cancer. Now the first problem is that the average American doctor spends 5 hours a month reading, upkeeping his medical literature for his profession. I don't know about you, but I spend more time in the weekend with the New York Times. The second is that most doctors suffer from filter failure. They get so much data on them, and they have like 15 minutes as an oncologist to see a patient and intake before you have the next. So what we said is, let's use this technology. One, it has a lot of unstructured data. Two, most of my team is around 50, and we want this stuff to be available when we hit 60. Great motivation, by the way. Our board, who's in the same category, bought that argument. So what we see here is, and there's a TED speech with much more details, but for the sake of time, this is what the oncologist has. It's already had an intake with the patient babbled, took all the data, not just from in the hospital, not just from the test results, not just from the family, not just the emails from the GP, not just the forms, not just the scribble on the forms and a bed note. You know, when you get the forms and you fill into your drink, you say, I'm Norwegian. No. Well, a glass a day or two. And that's what you mumble to the nurse. Do you smoke? Not really, just a cigarette a day. But you say no, and then you say to the nurse, well, a cigarette a day. And the nurse scribbles that up, but that never makes it to the system. So in this case, everything is scanned, everything is put in. And while the doctor has the intake with the patient, he gets to test options to consider. And in the diagnosis, this doctor is like, yeah, this piece of technology is not going to take over my job. This piece of technology is not going to do what I'm doing. This piece of technology filters for me, but I still like to know the evidence. How did you find it out? Well, it presses the evidence and says, okay, these are the references, etc. Yeah, that's really nice. I want a few more of this. So show me how you get this. Like, okay, there's a nice study. By the way, that's Dr. Wu. I don't like Dr. Wu. Tell me the test options to consider if Dr. Wu's study isn't in it. And slowly this doctor gets a filter online real time. But the most important what happens, it also takes the patient preferences there. So if you're this oncologist, and there's this woman sitting in front of you crying for 15 minutes, whatever you do, I'd rather die than lose my hair. I'd rather die than lose my hair. That's what most doctors skip because they look to the treatment. But that's what this technology picks up too, because it also takes the unstructured data from the patient. But then the third part is, okay, how do I share this? And you know, sharing is caring. Well, let me give you an example, right? Data sharing is the new black. We already share pictures, we share music, we share updates. Well, the next thing what we are seeing in this project is that when I find something, I want to share this with someone else in my business. When I ask, for instance, to this technology, what's going to be the best-selling toy this Christmas, and I find something, I was like, well, what is dependent on? Well, it's dependent on the flood that was just in Thailand if electronics are going to be produced or not. And at that moment, it's really pretty handy to know who else is doing this analysis. Can we share data sets with each other? Not by exporting them in an Excel. You know, Excel is like rabbits with Christmas. You get 2 rabbits with Christmas. By the time it's New Year's, you have 46. It's the same with Excel. So you give 1 part to your business, and 40 hours later, you have 46 ones. So data sharing is so important. Visualizing it, unleashing it, but sharing. And then prediction. Everyone talks about prediction like this. This is not prediction. This is not prediction. This is extrapolation. People who like this coat will take this shirt. People who like this belt will like these shoes. That's extrapolation. You know? When you used to go to high school, and people came to you and they say, oh, I just heard a new song. You say, oh, that's great, I'm going to buy that too. But who told these people what that first new song is they were going to like? It's easy to look to the playlist of my friends and steal their taste. But who is going to predict, and as the previous speaker says, who's going to predict that you suddenly get a business model that's more than coffee that's going to be successful? Who's going to predict that instead of charging 50 cents for a cup of coffee, I can charge $4.95 and I get away with it? Who's going to predict what my customers want? Not extrapolate, because if I extrapolate, I take the traffic around Oslo in the morning at 9 o'clock and say, oh my God, this is growing and growing. At 4 o'clock, this city's going to explode in traffic, right? Not taking in consideration that, I know, predicting is hard, especially about the future, by the way. And so from predicting, we go to cognitive. Now, what I'm going to show you is something we launched this May. So I'm not doing a product pitch. This is first of a kind. We're doing this with 12 clients. The bulk of them are financial or telecommunication institutions. What we said is like, what if we not only support doctors, medicals, bankers, call centers at their work spot? What if we would bring this to the consumer and we let it learn from the consumer how it wants to interact, and we let it learn from our bank or our telco and the world outside. So everything you and I are saying about a product, about financing, about mortgaging, is taken into consideration with the papers of the bank and the references and the advice a salesperson would mostly give. The sad thing is, 1 out of 2 calls in a call center goes unresolved. 1 out of 2 calls in a call center is either not satisfactory or needs escalation. Sad, eh? 1 out of 2 calls, if you make it, because mostly after 20 minutes you hang up. So we had this like, let's use Watson technology and use smartphone technology at the front end. So I'm not going to do the whole demo, we don't have time for that, but I'm going to give you the highlights of this. So in this case, we have Melissa. She, through her social media, actually came on the bank's website or the bank's smartphone site, and Watson says, hey, and this is just text, no speech even, because you know the problem with speech, it's really dangerous, right? Any one of you uses Siri? Because when I use Siri and I say, text my wife, I love her, my wife gets a text message, I love her. And I have some explaining to do, you know? So so we had to like, let's get the speech out. Let's just start with text. How much will it cost to send my daughter to college? Well, let's ask that. That's a really nice question. Let's read some bank articles. Let's read some forum posts, catalogs, policy. Oh, by the way, who are you? Right? Also nice to know. Who are you? Because I need to know who you are. Well, you're my customer. I know you live in Texas. I know your daughter is 2 years old because you open a saving account. I know you're 20 years old. All these things I now know. And I read all these things within the firewall, outside the firewall, and in the stuff you have allowed me to read. And then I say, well, given the fact you're in Texas, you have a daughter, you're 28 years old, it's going to cost you $135,000 for a public school or $345 US dollars 2030 for a private. And we continue this conversation. Well, because Melissa says, like this doctor, yeah, that's really nice, but how did you get that? Okay, these are my top responses. Now, Melissa could have Googled that, but could she have trusted the results? Because when I Google Hilton Paris, I get the socialite for 46 pages. And that's okay, because I pressed I feel lucky. But I actually wanted to find that hotel in the capital of France to have a romantic getaway. And so do I trust what I get? So again, she says, well, show me the source. And she gets the source. Now, what happens here, we take large volume of unstructured and structured data. We take normal human language. We come with all kinds of hypotheses. We then go in a dialogue. We validate. We ask questions like, Is this still your telephone number? Is this still the number you want me to use? Is this still the bank account you want me to use for this? Now, why is this important? Because we always tend as companies to ask the same question twice. If you go back to your business and you want to have one thing to score to improve customer value, get the business to stop asking the same question twice. It's so great, you go to a bank, you renew your mortgage, and then they say, what's your address? It's like, oh, really? Really? You know, the one where we have the house where you had a mortgage. And don't ask me the same question twice, but validate things. And learn from the validation. Learn how I use it. Learn where I tap. Learn what I ask. So cognitive technology is about understanding language, working with hypotheses, working with structured and unstructured data, and actually learning from the interaction and sharing that learning. So, for those of you that said, that's really nice, I need a framework. I really need a framework. I said, well, you know, in the old days we said, classic business intelligence, what the heck is happening? We looked in the rear mirror of our car and we drove from Oslo to Tønsberg. And we looked in the rearview mirror how much petrol we had used and what was behind us, and not really what was going to happen in front of us, how much petrol we needed, and where we were going. And it was better than gut feeling to take decisions still. Then we went to predictive, which was mostly extrapolation and simulations, and predictive was as good as the assumptions our data scientists had. And then we went to prescriptive. We did optimization, you know, like, well, if this happened and if the traffic takes down. And now slowly we go to truly saying, what patterns do I find in all the data to predict that people would be willing to pay $5 for a cup of coffee? What will be this best-selling toy this year is not an extrapolation of last year's best-selling toy. It's an extrapolation of all the patterns that my customer have that make them buy last year Iron Man or the Avengers as the Lego or towel or lunchbox things for the kids. But that came from other things. It didn't come because it was a Disney movie, because no, it became what were people talking about, what was the buzz, what was in production, what was the response. It came from a lot of unstructured things, how you could take that. So, let's go summarizing. 5 things to do. You go back to your business and they say, oh, we want all this stuff. Like marketeers. I used to be a marketeer for years. Before I joined IBM, I was an IBM client and I worked with marketing and I drove people crazy by spamming them. And then I saw the light. Nothing more believable as a repentant sinner, right? So first is, okay, you might want to do cool things in marketing, but let's start with what are the most important questions you want? And let's unleash the big data with it. What would be the most effective way for your people to visualize it? And let's focus on that. Would you want to do that standalone or share that? You know, do you want to share from the back office to all the store managers, or you just want a happy few to do? Or do you want to make it for the masses? Do you want to give it to your consumer? Do you want to give it to your customer to give to their customers? Do you want to predict? Do you want to add some smartness? And summarizing for you, going back to your company or going back to your customers, always start with a problem. Why are we doing this? What's the value we're going to get out of this? How is this going to give us money? Listen before interacting, reacting, and predicting, especially to consumers. Don't start saying, oh, I have big data, let's ban them. Like, go through all these social buzz. A lot of people are talking in the web about Maseratis. I'm one of them. That doesn't mean they have the intent or the ability to buy one, sadly. There's a big difference between the buzz that somebody likes something and the intention to buy or the joy of ownership. Separate these things. Share data to get data from consumers. Instead of talking privacy, start saying, this is what I know about you. Help me to make this better and tell me which part you want me to use. And by the way, if I can use it, I'm willing to share some of the profits. Look to customer-centric metrics. Already the previous speaker shared this with us. Let first computers analyze and find connections between big data before you start doing it, and work on visualization. If you can't do these things, cognitive computing is still 3-4 years out for you. So that's the reality. Watson is a great thing, but very few companies, and the thing is, most companies think it's a selling pitch when they say, well, you're not ready for it yet. Oh, now I want it, I will pay more. But it's like, you know, going on a date, and she says, no, I don't know if you're worth my time. Oh, I am. I mean, it's not that I'm in a golden retriever approach, it's truly that you need to have some maturity, governance, and ownership to do this. So, summarizing, we think we're on the cusp, the breaking line of the transition between a new way of using technology. It's going to take 3 to 6 years before this is mainstream. But what we see from the first companies in the world that we're working with, this is humongous in impact. It transforms the way you think. It transforms how the ownership and marketing and sales is. It learns through interactions, and it works on evidence. And this might be more important than this. It doesn't give the absolute answer. It gives the this is more likely answer. I mentioned some things. I have a TED speech. I have several papers with my co-authors on this topic, including numbers, etc. I'll put them on the Twitter stream after this. This is the Twitter handle at Marc Teerlink. So if you really want to know some more stuff, I'll put them in a few minutes. If you go to the TED speech, do press like. My boss watches. So thank you so much. Thank you so much. Jij mij tak nemen het weer hier. Tak.